How PWM and duty cycle works. PWM is used throughout the automotive industry as a command signal. It is meant to make automotive components work less, when the demands are not as heavy. And we created the PWM bidirectional controller to help you test and diagnose all solenoids, motors and actuator components. PWM, or pulse width modulation, is the ability to control a load or component by pulsing its electrical current. In this way, the load or component can be made to change its speed, without any heat-causing parts, like resistors. So, if PWM is using pulses to control a load, then duty cycle is the measurement of these pulses. The duty cycle of a PWM signal tells us the amount of work this signal is supposed to make the component perform. The duty cycle of the signal is always described in percentage. So, a 10% duty cycle means that the component is on 10% of the time, and a 90% duty cycle means the component is on 90% or most of the time. Now, there is a close relationship between duty cycle and how the component is triggered or turned on, which could be by applying power or ground. This relationship is very important, so remember that thoroughly. Here is what we mean by that. Suppose a solenoid is activated by ground. That means that 12 volts or battery voltage is applied steadily on one side, mostly through a relay, and the other side receives a PWM ground command signal. Now imagine that a 10% duty cycle PWM signal is applied. What we then have is to measure is how long the signal is grounded, and how long as compared to the entire cycle. A 10% PWM duty cycle means that the solenoid receives a ground only 10% of the time, and receives power 90% of the time. Since we have already mentioned that this is a ground-controlled solenoid, the time the drive transistor provides power means that component is off. Why? Because you already have steady power on one side, so power on the other side equals no operation. If, on the other hand, the component is turned on by power, meaning ground is steadily applied on one wire, and power is pulsed, that same mentioned signal will then become a 90% duty cycle signal. Now with this power-actuated component, the positive or 12-volt side is what matters, and what is taken as the duty cycle. It is worth mentioning that most components are triggered or actuated by ground. Why? It is because if that command signal is shorted to chassis ground, the component will simply turn on all the time, like a 100% cycle. If it were power-triggered, then there would be a short, and the fuse would blow, rendering the system useless. But still, some components are power-triggered, and be prepared to understand the nature of PWM to duty cycle. Hopefully what you have learned here will give you some insight on using the PWM bidirectional controller to perform your diagnostics.